Okay, video 2 about for data validity and error checking and data cleaning. I'm hoping that people find this useful. It's weird to know where the line is because it's such a on a case by case basis for how one cleans one's data that I'm sort of pointing out the high level views of things, but not exactly the nitty gritty details of how one checks for certain things. So for data validity, how do you validate data? Well, there's a number of different things. For example, you can do just type data type constraints. So like the salary must be a number, or this must be a string of text. It cannot be, or it must be only numbers in there, or it can only be alphabetic characters, or things along those lines. Or maybe you can constrain it so the final grade is between 0 and 100, or the amount of money per year that you make is below this, from this much to this much. You can have mandatory constraint fields. Let me just double check what I actually wrote here. So, mandatory constraints, so that the last, you need to provide a last name, for example. And if you do not provide a last name, then this whole thing blows up. I'm going to look at the calendar for a second. You get that often with, like, you need to supply your email, you need to supply your ID. You can't do it, you cannot progress any further without that. So that you don't have missing information that's absolutely critical information. Or that there's a constraint, so like a social insurance number has a particular format, 9 digits. So maybe, or membership constraints that only first degree or second year students can enter this, or that you confirm that you're 18 to use this. Maybe there's a foreign key, so that if you were filling in all this stuff, you must be listed. The degree you list must be at a Carleton degree, and you can validate something about the data. You can go off, check to see if that field is actually a valid field. So you check with the database to see, hey, is this one of the fields we have? Or maybe you use a regular expression. There you can do entire courses on regular expressions, meaning that you are matching a pattern of text or symbols based off of a formula. So it has the format, there's a wildcard, then it's at carleton.ca at the end. Or maybe there's a bunch of alphanumeric characters, there's an at symbol, and then another bunch of alphanumeric characters. Or you can also think of cross-field validation, meaning you can validate or check what you did by, the sum of all these values has to add up to 4,000. The sum of all the lab grades adds up to 30. And if it doesn't, well, maybe one of the numbers that you put in are wrong. The checksum is a classic example. When you're downloading a file, it has some way of checking to see if you downloaded the file correctly, because when I forget how the mathematical way that a checksum works, it is confirming that all the various files all the various packets your file was sent as sum up to some number. In either case, you can always validate what you have by just checking to see if, or you could say that if you're supposed to make 30%, the other person did 30%, the other person did 30%, well, that doesn't add up to 100%, right? That's a way of validating. If you know when things total up to some value, or this minus this gives you this value, you can actually validate the field that way, mathematically. All of these cases are places where you would want to make sure that when the person is inputting the data or when the data is coming through, that you can flag or catch or identify when things go wrong. This is what asserts are normally when you're doing, when you're programming something or a unit test, that whatever happens, you would expect this not to be the case, that the index is not outside of the array. If it is, then you have something wrong in your code. Right? This is the same kind of thing that we're doing here. You just double check if you find ways that you can constrain or verify that the data has not been corrupted or it has not been input incorrectly. That is a key first step in preventing you from getting bad data. The quality itself is validity is just one part of it, and the integrity of your data is one or the other term you get thrown around, which is related to but not. It includes validity, but it's not sufficient to just have validity for the integrity of your data. And it's somewhat of a nebulous term. But in terms of quality, data quality, I would like to say integrity is very similar to validity. It is that it works, that it's complete, and so you see data quality and data integrity used somewhat interchangeably. In terms of data quality, you're talking about is the accuracy, is the data accurate? Does it match the ground truth or the gold standard for the data? So if the data coming in does not match what you would expect or what you know to be true about the data, that's a big red flag, right? If it's not accurate, then it's not actually, you're looking at the wrong thing. So if you misrepresentative sample of a bunch of users about the US election, then it's not going to be accurate. It may not be accurate data. Are you missing some things? Are you missing particular fields? Are you missing certain submissions? Are you missing information that's necessary? For example, your submissions for the survey that we did, right? If you left off a whole bunch of those fields, are you sure that is the quality of the data there for us to do a proper analysis if half of you left off what your favorite color was as one of the fields? So how persistent or how consistent is it? So the precision within a row, that would be, so the person always, you don't get this huge swings. You ask the same question or the same kind of question about political leanings and it's consistent. You always vote for that person, or you always have conservative views, or you always have a view that matches the questions between each of those fields sort of match each other. And then you have across rows, you have uniformity. That would be everybody votes that way for this particular field, or everyone's fairly consistent with are puppies cute? Yes, everyone says puppies are cute. And when someone says no, you go, whoa, there's something wrong with your data, right? You may not like puppies. I was just coming up with some example that I thought would be safe. Uniformity would be across the different rows, different people putting in their data normally give the same kind of answer for this same question. It's different people, but they're giving the same answer. Versus consistency is, I am consistent with my responses. When I do surveys, oftentimes I will intentionally switch the question around just to see if you get a consistent response, or if that they're actually reading the question. So this is one of the things one of the things you want to be able to validate. And if you don't have consistent data, you can think about throwing out that person's data if it's appropriate, if it's deemed appropriate. How you clean data is a different beast. So there's a bunch of different things. So right now for bit 1400 and bit 2400, we're doing lab exercises. And when they do the lab, they submit their lab work to See You Learn, and we give them a grade. So if they submit anything at all, we give them a grade. It's a non-graded grade. Of course, the first thing that people are going to do in that case, or a lot of less honest people are going to do, some subset of the population in this case, what are they going to do? They're going to just submit like the original file, the starter file, some random file that they find. They submit it to See You Learn, and hey, they submitted their homework, and no one's the wiser. So what we do is we're doing a random audit. We take a subsection of the class, some subset of the class, like 4 or 5 students, let's say maybe up to 10, and you just quickly glance over what they submit to make sure it seems valid. We might be doing this with the Google Drive stuff as well, in case you're wondering. So you submit, you check a random subset of what people submitted. And if somebody, and so you can audit it in that respect, you can just take a random subset of people, see if the data looks good enough. If it's truly random, you're hoping that you have if you grab any, say 5 records from this data set, if these 5 were chosen at random, you choose any 5 at random, and there's a pretty good chance that the data is still good, it's still clean. What we did for data auditing for us, slightly different beast, is we take a random subset of our students, see what they submitted, if they submitted anything, and if anybody doesn't submit their file, just try to fake the system and submits like a blank file, we then audit their previous submissions afterwards to see if we have some kind of pattern or some kind of regularly occurring issue. And you can trace back what the problem is. We can specify the workflow itself. So how do you process it? How do you find anomalies? And you formalize all of these various parts. Or how do you process data, having some kind of formal mechanism for how you process and how you go through all of this, how you go through this cleaning process. And then after you're done with this, so you initially audit a random subset of your data. You specify how you're going to process the data. You then execute the workflow process, making sure you process your data. And then afterwards, you check again and see if the data has been cleaned or if there's anything that happened. You often have with a large data set that you cannot check everything. So some of the best ways you can do things is just to be monitoring as you go and hope that something doesn't sneak through. If you do a large enough random subset, hopefully statistically nothing's going to get through. Some things might, but it shouldn't be as big of a deal as like a consistent error or a consistent problem in the data. And how do you find it? Well, first of all, you can parse it and do validity like we talked about already. The data transformations themselves, we can just change the format to hopefully like either make the data more obvious or to, as part of the transformation, clean things up or make sure it's in the right ranges. For example, you could make sure that there are all whole numbers instead of floating point numbers to avoid rounding errors and just keeping with whole numbers, for example. You can get rid of duplication. Finding duplication is a relatively easy-ish task, and getting rid of duplication will hopefully improve your data. And you can do outlier detection. So from a statistical standpoint, you can actually analyze what the kinds of responses people give for these questions, how extreme some of these answers are, and if someone's really off, the system will show it up, right? So if you use something like the standard deviation, SD is what the SD is here for. If you use something like a standard deviation, you can, if you're 2 standard deviations off of, and you know that the data is normally distributed, we'll look at stats soon. If you know that you get this nice bell curve of your data, and this person is over 2 standard deviations away from the average, that person's really off the beaten path. And there are different models you can do. There are different philosophies about this. But if you have a really extreme person or a really extreme data point, you can actually safely remove that data point and not screw up the rest of your data. It's actually, there might be some error that was introduced into your system. Sometimes when you're talking about survey data, there's somebody that goes and writes 1 for every single answer just to be a jerk. Did you like this? No, I hate everything. Right? Just to see what would happen. You need to be able to find those people and remove their data from the data set. You expect that, but that person is anomalous compared to everyone else, and that if you can find anomalous data, you can throw it out. Harmonization and normalization is to try and adjust your data to fit into a particular to have sort of the same range. It's an apple, instead of an apples to oranges comparison, you have an apples to apples comparison. So harmonization allows your data, as if you transform the data so that this is on a 5-point scale, this is on a 5-point scale, their ranges are around the same, that would be a normalization. It's trying to map the data of different fields so that they work together. Or we can also fill in missing or incomplete data, or put in, you can sometimes, depending on who you are and people that are doing data mining or data, professionally doing data analytics, anyone that's in that group, you can talk far more about enhancement of the data, the proper statistical way of doing this, filling in, let's say, the average value for a missing value or for incomplete data. Seems like it would potentially be able to throw off your data a little bit, but it's better than having you assuming that 0 is the default if someone doesn't submit something. You also might hear the term, and so enhancement's a whole other thing, and what is appropriate enhancement at various times. We already talked about precision, actually, so we'll just skip that. And then we have the idea of a strict versus a fuzzy validation. A fuzzy validation is you're validating the data, but you're not being draconian about it. A strict validation is it has to follow this particular pattern. Fuzzy is, most of the time it has to hit this particular pattern, right? Anytime you're talking to university professors, oftentimes they'll give you fuzzy validations for things. What do you need to do to pass this course? Well, you probably should have a pretty good project, maybe, sort of. Strict would be your project has to hit these particular metrics. This one is like, it seemed pretty good. It's around the right A range, right? It's approximate. Strict versus fuzzy. The fuzzy validation is if it doesn't match your data, how off from the match is it? And then you have to make a judgment call of where you cut that off or where you say that that is incorrect. So I would love for you to do this exercise. I think this is probably we have three more slides. So I would like you to take time for a second, and we're going to do this as a Google Drive thing. Don't incriminate yourself too much, but you can also be, you can't be anonymous, I suppose, but hopefully you won't incriminate yourself too much. I want you to recall a time with a data set that you used in the past where you had to clean it. So it had to have been cleaned. If it was already clean, it doesn't count. So, and what kind of validity checks did you do? What kind of error sources were in there? What kind of problems did you have? What kind of transformations of your data did you have to do? Anyone that's had to deal with a large amount of data before has gone through this particular exercise. And if you haven't, well, hopefully you have. I'm assuming most people have done this, even if it involves their coursework or having to deal with a spreadsheet at some point in time. The scales are going to be different. If you're really struggling to find something, please let me know. But most people have dealt with some kind of thing like a log file or survey data or something along those lines. And what did you have to do to clean it? And I wanted to sort of have a description of what the data was and what it was for. But the most painful story about what you had to do to clean your data or find error sources or all the heartache you had to go through involving this data set, the person with the worst example wins. So if it was like you had to manually type in everything all over again because it was all broken and it all caught fire, that's a wonderful example. That's horrible experience. I think I was doing data entry for Sears catalog as a summer job one time, and you had to manually Photoshop every last little pixel, and it was done by person power, not computational power, to edit all of these photos for Sears catalog that was online, and it was just this arduous click experience. It was not so much fun. So in summary, when we're talking about data ingestion and cleaning, that's not the focus of the course. That's why it's only half of a lecture even. But it is part of your data. It is normally a huge part of the data analysis process. It's just normally saved for another time, another course where it's heavily studying the statistics. We're looking for the pain points associated with this, not necessarily the how to do it. What I would love to look at more is how we streamlining aid human validation. And so that is part of what we're trying to look at for this course is how do I find it? And when I do find it, what do I do? How do I clean it up? How much of a pain in the ass is it? What kind of approaches could we do to streamline things? Quality assurance has massive ramifications of how your data is used. And if your data is not correct, what conclusions you make about your data are essentially wrong. I like to point out the fact that a lot of people think that just throw more data at it and you get more accuracy. But in fact, if your data is crap, you don't get more accuracy. If you just do more samples, but it's all crap samples, you get precision, you don't get accuracy. Accuracy comes with correct data, not with just more data points. So getting correct and complete data, not partial data, but correct and complete data is actually the key. I like this quote just because, well, I'm juvenile, but I think it's funny anyways. I like the idea that everyone was talking about big data and it's the next big thing, and it probably is, but it's somewhat of a nebulous term, and I think a lot of people are looking for another gold rush necessarily, and there probably might be gold in there, but it's a lot harder than people give it credit for. Everyone thinks everyone else is doing it. Everyone thinks there claims that they're doing it, and it's still new territory. So, throwing unclean data at a problem doesn't necessarily solve your problem. We need to make sure we find ways to track and catch and screen out incorrect data. All right. Thanks, everyone. I will talk to you soon. We are going to go on to stats next, and we'll look more about validation and we'll look at standard deviations and the like. All right. Thanks, everyone.